Okay, now we're on to section 4.3. That's with equations with variables on both sides. Okay, Algebra 1. We're going to go straight to the examples again. So, our question says 3x plus 55 equals 8x. So now instead of having the x's all on one side, we have x's on the left side and x's on the right side. So the idea is that we want to get all the x's on one side and all the plain numbers on the other side. So we're going to keep 55 on the left-hand side, but we're going to move 3x to the right-hand side. And the way that we do that is by adding the opposite. So we're going to add a negative 3x or subtract a 3x from both sides. And 8x minus 3x would be 5x. We want to divide both sides by 5 to get x by itself, and we get 11 equals x. And I just don't like looking at it that way, so I like to rewrite it as x equals 11, but you don't have to do that. Okay, let's check our answer. 11 plus 55. That equals 8x, or 8 times 11. 3 times 11 is 8 times 11 is 33 plus 55 equals 8x. So we have the right answer. Moving on. So here we're going to do some special cases. You really need to know. These are important and they don't go away. So we do more algebra and it gets more complicated, and we'll still have these special cases. Example 2, we have 5 minus 9x equals negative 9x. So you're going to start it the same way. You're going to add 9x to both sides to get all the x's on one side and all the numbers, plain numbers like 5, on the other side. So we have 5 equals, now negative 9x plus 9x. Those are additive inverses. We add them together and we're going to get 0. We get 5 equals 0. Does 5 equal 0? No way. That just is not true. So we call this a false statement. This is a false statement. This is not true. And when we get a false statement, the answer is there is no solution. Isn't that crazy? So what you want to write down is no solution and box it. That's a special case. So we have another special case we're going to look at. What happens when we get a true statement? So in example 3, we have 4 times x plus 3 equals 3x plus 12 plus x. So we're going to distribute the 4. I'm starting to get really good at algebra. I'm going to go ahead and combine these two terms, and I'm going to do 2 steps in one. So 4 times x is, is 4x. 4 times 3 is 12. 3x plus x is 4x plus 12. So remember, when we have an x, we have an imaginary 1 in front of it. So we do 3 plus 1, we get 4x. Okay, so I'm going to get all the 4x's on one side. I'll subtract 4x from both sides. And I get 0 plus 12 equals 0 plus 12. So then I get 12 equals 12. This is a true statement. True. And what this means is that any real number works. So we could put any number in for x and we would get the right answer. So what you want to write usually in the box is all real numbers, and a shorthand for all real numbers is an R with 2 lines. That stands for all real numbers. So you can write either one of those. It's nice to have the shorthand, but you have to do it correctly. You can't just write a capital R. That's not right. You got to have that extra line there. Okay, so I just want to show you. So suppose x equals 0. Okay, let's plug in 0 for x and check. So 0 plus 3 is 3. 3 times 0 is 0. 4 times 3 is 12. 0 plus 12 plus 0 is 12. Your statement. So what if x equals 1? Is it going to work for that one? 4 times 1 plus 3 equals 3 times 1 plus 12 plus 1. 4 times 4, 3 plus 12 plus 1. 4 times 4 is 16. Uh-oh. And 3 plus 12 plus 1. Oh my gosh. I don't know what I pushed, sorry. 3 plus 12 plus 1 is also 16. So you could put in any number for x. You could put in 1/2. You could put in 0.35678. Doesn't matter. Anything for x is going to work because the answer is all real numbers. So those are all our special cases. And that's it. We're already done.